Hello, everyone. Good morning, good afternoon, and good evening. Dear author and invited guests, welcome to a technical session 5A. Myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation and the GR Solistic LLP, it's my great pleasure to welcome you to the 9th World Conference on Smart Trends in System Security and Sustainability WS4 2025, London, UK. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held in London, UK on 19th August 2025, while the virtual sessions are being conducted by Zoom on 20 and 21st August 2025. In this session, we have a six presentation. Each presentation will be given 12 minutes for presentation and a 3 minute for question answer. After 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us through the closing remarks. If you have any query or any update, write it to me in a chat box. Just before we get started, I would like to introduce our chair of the session, Professor Narendra Londe. Professor Narendra is presently working as a professor in the Department of Electrical Engineering of National Institute of Technology, Raipur, India. He has a 15 years of rich experience in academic and research. His main research interest is medical signal and image processing, biomedical instrument, speech signal processing, biometrics, intelligent healthcare, brain computer interface, artificial intelligence, and pattern recognition. I welcome to you, sir. Now I would like to start with papers. I would like to invite the paper presenter is Friska to present his paper on a conceptual model of data integration security in a smart city data-driven decision making. Dear presenter.
Okay. Wait a minute. Okay, thank you for the opportunity. Can you see about my screen?
Yes.
Okay. Good morning, everyone. My name is Friska Nalusya from Telkom University, Indonesia. Today, I'm honored to present our research entitled A Conceptual Model of Data Integration, Security, and Smart City Data-Driven Decision Making. This work is a collaboration with my colleagues, Aziram Dani, Fajar Hardiana, Andi Abdul Hanafi, and Dr. Yuli Adam Prasetyo. Together, we hope to contribute to advancing secure and trustworthy smart city decision making. By 2050, more than 68% of the world's population will live in urban areas. Smart cities promise better public service through data-driven decision-making, powered by IoT, sensors, and cloud computing. But with more connectivity comes more risks, cyber breaches, privacy violations, and attacks on critical infrastructure. Our review shows that over 60% of studies focus only on technical security, while very few attempt to integrate security, regulation, and governance. This is the gap that motivates our research. Emerging technologies like IoT and cloud computing create new opportunities for smart cities. At the same time, they expand the attack surfaces. For example, a man-in-the-middle attack on traffic sensors or data leakage from an edge node. This means every technological innovation must be matched with robust security mechanisms. Our literature review shows that existing studies cover important areas such as failure encryption, MPC authentication, federated platforms, and GDPR compliance. However, each of them is isolated in one aspect but limited in cross sectors, scalability, lacking integration, or without technical implementation. And then what's missing is undefined model that connects for critical domains. For the first is data integration. This step is ensuring data from multiple sources can be combined consistently and securely. And the second is security technologies, protecting data confidentially, integrity, and authenticity. And the third is regulation and privacy. This step is guaranteeing compliance with laws, okay, and safeguarding citizens' privacy, and the last is governance, providing oversight, auditing, and crisis response. From our systematic literature review, about 40% of studies focus on technical aspect, 25% on regulation, and 20% on governance, and non-fully integrated all four domains. This is exactly why we propose the DSDMC model. Our research objective, uh, our primary goals is to develop the DSDMC model that supports secure decision making in smart cities. We address four main questions. And the first is what is data integration security in smart city, and then how is security applied during integration, and then which technologies can protect it, and then and how we can regulation and governance be integrated. For this research, we adopted a systematic literature review, or SLR, using Kitchenham and Prisma guidelines. From an initial pool of 28,926 papers, we narrowed it down to 58 high-quality studies, covering the period from 2019 until 2025, and indexed by IEEE, Springerling, and Scopus. And the next is to understanding data integration security in smart cities. Data integration securities refers to protecting data during the entire process, like collection, transfer, integration, and storage. Over 70% of studies emphasize IoT and cloud as a key enablers of integration, but also as major contributors to new attack surfaces. For example, securely combining traffic, environmental, and energy data for real-time decision making. And then for implementation of process, we found in the literature include layered architecture, middleware, API-based integration, ETL pipelines, and edge computing. Key challenges remain about latency, data inconsistency, poor quality, and lack of standardization. And then about the applied security technologies, we use the literature suggests four key study categories of technologies. For the first is encryption, like AES and RSA, and failure, and then authentication, like MPC, digital signatures, and then integrity, like watermarking. And the last is detection, like AI-based anomaly detection. Interestingly, over 75% of studies recommended combining of encryption with anomaly detection for best result. And then for regulation and governance, we have a technical security is not enough. Regulations such as GDPR ensure transparency and accountability. Governance frameworks transform response from reactive to proactive, track policy monitoring, adoption model, and then AI auditing. However, the integration of technology with governance is still rarely implemented in practice. So, to fill this gap, we propose the DSDMC model, which integrates four domains. For the first is secure data integration, and we can see about the screen, like data integration from multiple source and then fuzzy decision making model, protocol, encryption and watermarking, and many others to ensure data heterogenesis. Data from IoT, sensor, and cloud can be merged in a consistent and secure way. And the second is security technologies like IoT security, and then failure encryption, MPC authentication, and many others to providing technical protection such as encryption, authentication, and anomaly detection. And the third is regulation and privacy, um, like regulation frameworks for data storage and then GDPR compliant data sharing protocols. Uh, to this step is ensuring data compliance with legal frameworks while protecting sensitive citizen data. And the last is governance to enable continuous monitoring, auditing, and effective crisis response. Together, these domains form a secure, adaptive, and trustworthy framework for smart city decision making. And the next is how the DSDMC model supports secure DDDM or data decision making. For the first is scenario 1, a man-in-the-middle attack on traffic sensors handled with encryption and then anomaly detection and policy isolation. For the scenario 2, data exfiltration from an edge node and then handled with MPC authentication and then real-time logging and regulatory escalation. This scenario demonstrates that the DSDMC model is not only technical but also institutional. And last, in conclusion, the SDMC model bridges the gap between technology, regulation, and governance. Our future steps include piloting the model in transportation and energy sectors, and then capacity building to cybersecurity and data professionals, and then aligning local regulation with international standards and encouraging collaboration among governance, industry, academia, and citizens. Only through multi-stakeholder collaboration can we achieve a truly secure and sustainable smart city. Thank you very much for your attention. I look forward to your question. Thank you.
Sorry, do you have some experimental data about your conceptual model, which gives some evidence about this model, how it could properly execute really to achieve some objective you have talked about? Do you have some evidence, data of this conceptual model? Thank you.
Thank you for the questions. Why we choose about the conceptual model first, like evidence first, testing next. Jadi SLR maps the global state of the art. The next step is the real world pilots. And about the data, we make a research like grouping our paper that we found at IEEE, Spingerling, and Scopus with SLR or systematic literature review research to find our based on keywords. Thank you.
Greetings to Professor Libro. Sir, this is Professor Narendra Londe from NIT Raipur, India. Okay. Sir, namaskar from India, sir.
What is the next presenter, sorry?
No, no, sir. I'm one of the session chairs, sir. I just said greetings to you, sir. Good morning.
Morning.
Sir, sorry, sir. I actually joined late, so I'm extremely sorry, sir. And we can call the next presenter, sir.
Yes.
Thank you so much, presenter, for your presentation. Now we can call our next presenter. To present is a paper on abrupt concept drift hybrid machine learning using three-way decision A and K nearest neighbor. Dear presenter, please present your presentation.
Hello.
Hello.
Yes,
you're
can you see my
audible.
presentation?
Yes.
All right, thank you very much. Now, I'm Jeffet Ndiek presenting on a abrupt concept drift hybrid machine learning using three-way decision and K nearest neighbor. I'm presenting from the University of Jomo Kenyatta in Nairobi, Kenya, and I'll be presenting a layout on this, and I'll be looking at the statement of the problem for the topic. And the understanding of the topic is that we know that KNN suffers from overlapping datasets and spectral data. And by these, we understand that the correlated disjointed data features, which consist of nonlinear and the complex data processes, and the data noise specifically affects the outcome of how KNN can be able to perform. Now, in this particular subject, we also note that in the incoming data sets in the KNN, we understand that it cannot be able to generate trainings, and this generation of the trainings is caused by the outliers or noise, which causes the concept drift detection algorithms. Now, in these outliers and noise that comes in with the heterogeneous data that continuously streams in, causes a concept drift, which is the major problem that we are trying to solve in this particular experimental analysis. And in our adoption of an hybrid three-way decision making in the context of the KN settings, we are involving three data points, that is the positive, negative, and the boundary. And precociously, we present this to provide clarity and ambiguity so that we can be able to solve the uncertainty in the large data sets. We also note that the boundary domain has the ability to improve classifications, and that is one of the experiments that we are carrying out in this test to determine and solve the imbalanced data and noisy data sets. So we combine the three-way decisions to provide clarity in the overlapping classes and data sets with inherent uncertainties. So our main objective, our main objective is to develop and evaluate a hybrid machine learning based on a three-way decision in the context of the KNN for crop yield prediction. And basically in that, we design questions based on the experimental design. And our first question is to look at whether the proposed three-way decision and KN classification model is competitive in the classification accuracy and efficiency, and whether the dynamic weights impact the mean time accuracy of the three-way decision and the KNN classification model, specifically in abrupt drift detection, and to determine whether the instances of the K values and the dynamic weight size have an effect on the mean accuracy performance in the abrupt concept drift. And the last question is to look at whether the three-way decision classification and how it compares with other state-of-the-art algorithms. So the experimental setup is derived from the existing Obdin and Cargo machine learning repositories, and we are looking at the variable datasets. And the experiment is conducted in a BRAF concept drift in the machine, in the massive online framework, where we subject datasets into input, pre-processing, processing, and output levels. And we use Panda, which is a Python library, to read the datasets, and Skyline is also used to train the datasets, and we implement the model in the matplotlib where we use to visualize. So this is just the classification concept drift and three-way decision design model, which we are using to determine the model, and the datasets were put into this kind of properties. Now, how do we analyze the results, and how did we adapt the model to the implementation? So we use the three partition of the positive, negative, and the boundary for the concept drift in a three-way decision rule. So we set these rules in three major ways, where we are able to set the positive, the negative, and the boundary to be able to determine and set our results, so that we determine the optimal point of the classification to be able to determine where the concept drift occurs, so that we can be able to improve on our accuracy. And this is just the algorithmic model where we set the conditions for the training and the k-nearest neighbor and estimation of the boundary. And in one of our results, which answers the question 1, was to look at the mean accuracy of the 3KN with abrupt concept drift. And we had noted that we set the model into 100K instance, 200K instance, and the 300K instance. And we were able to note that the overall modification in this hybrid method that we employed is that we realized that the average accuracy were able to improve with instance sizes from 100K to 200K to 300K. And we were able to achieve the best level for the hybrid concept with the 95.7%. And we also noted that as the K value increases, so does the increment in the meantime value accuracy. So to answer our second question, we did the experiment on varying size of the dynamic weight, and we evaluated the classification based on the dynamic weights, which were set to 300, 500, and 1,000. And we were able to realize that based on this analysis, we projected and we produced different results based on the 200, the 300, and the 1,000 weights. And based on these weights, we noted that our projection and our dynamic weights produced that the hybrid three-way decision can performed optimally with the best accuracy rate, which was produced at the 500 weights with a 95.14% with an instance value of K. So we noted that in the abrupt concept drift scenario, the dynamic weights have significant impact on the mean accuracy of all the models that we studied. And the experiment did not go beyond the abrupt concept drift, because we know that there are different concept drift. So we were mainly focused on the abrupt concept drift. And lastly is to answer the question 4 and question 3 that was trying to look at the runtime analysis of the three-way decision. And having conducted all these experiments based on the data sets that we had from the Omdina and all that, we noted that the experiment in terms of the computational runtime to determine, which is a major problem in the KNN, we noted that there is a consistency pattern in how the three-way decision and the KNN achieve the best runtime accuracy in all the experiments conducted. So in the test run analysis, we determined that as the weight increases, the algorithm also slows down due to high computational resources. So it is better to test the algorithm on instances that are a little bit lower, so that you can be able to achieve at the optimum point. And also the computational time of the three-way significantly increases with the sizes of the windows as the KN values also increase. So that has a major influence on the performance of the KN and the three-way decision hybrid model. So in this project, our model contribution was to combine a three-way decision points of the positive, negative, and boundary with the dynamic weights computation, so that we can be able to look at and compare this hybrid model with other conventional algorithms. So we noted that our algorithm performed much better in terms of run times and in terms of achieving computational efficiency in the hybrid modeling test. So in conclusion, we note that the hybrid shows significant trends in applying decision points to improve the KNN accuracy in classification performance and test in heterogeneous and streaming datasets. We also note that the experiment results have shown the overall classification accuracy rates improved compared with other traditional KN classification algorithms in this study. And also we note that the significant performance of the hybrid model against other conventional in terms of average accuracy performance and the different K values were tested, and it suggests that there's potential for improving the KN based on a hybrid model. So thank you.
Well, I would thank you for this interesting presentation. I could ask you some details about your method. In which language it was implemented, first of all, and how do you deal with Sorry, there is a confusion in the voice. My question is, how do you My question is how to deal with the increased runtime when you have to deal with a big data set, a very big data set. And how do you exactly choose the key value in the KNN approach? In which way you choose exactly the key value, which is, I know, very, very important. Thank you.
Right. Thank you very much. This model was implemented using a Python library, and we note that the choosing of the K values is dependent, because if you use two large models in the KN values, you mean that the model will rely heavily on the older or previous concepts, and this will particularly hinder the ability to learn and adapt. And on the other hand, if you also choose very low KNN values, then you will notice that there is much sensitivity to the noise and outliers, which might emerge, hence reducing the robustness. So in oversimplifying the decision boundaries, you may fail to capture the important patterns, which may degrade the outcome of your overall efficiency results in the algorithm.
To complete my question, I would ask if you have thinking about the possibility to use some sort of parallelism when applying your model, because there, for dealing with the great runtime, which is encouraged in this application method. Thank you.
Okay, noted.
Okay, I have one more question. See, when we talk about machine learning algorithms, the 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 questions on generalizability and reliability comes, right? So have you ever thought about your methods in terms of its generalizability and reliability?
Yes, because in terms of generalizability, you realize that the algorithm performance is much affected by how the heterogeneous data sets come in. And in terms of the significance impact, of how the accuracy is affected by the generalizability is solved by particularly dividing the concept drift on the classes by using the three method. Now the three method based on the positive, neutrality, and the negative is able to solve the generalizability that may affect the performance. And that is why we introduced the three-way decision model in order to divide on the classification and provide accuracy on the classes that comes in with the new noises, new imbalance data sets, and all that.
Okay, thank you.
All right.
Richa, next presentation.
Thank you so much, President. And now moving ahead, we can call our next presenter, Sadia Sultana, to present her paper on developing an EEG dataset, EMEG, for the comparative analysis of brain waves across different emotional states.
Hello everyone, I'm Piyal Hassan from Shahjalan University of Science and Technology. I will conduct the presentation on behalf of my team. So today I will going to present developing an EEG dataset. 1 minute. Okay. So today I will going to present on developing an EEG dataset, EMEG, by comparative analysis of brainwaves for different emotional states. So now I'm going to take and give an overview about all of these topics during my presentation. So at first comes, let's start with the introduction. So neuroscientists for many days wants to know how brain actually works. So neuroscience studies using fMRI and EEG shows that there exists a frontal asymmetry, like the left prefrontal cortex of our brain linked with the positive emotions, and where the right prefrontal cortex always linked to the negative emotions. So in our study, we used Muse to headband, which is a wearable EEG device that can capture brain waves. And we collected data from 40 different participants in 3 different stimuli, like audio, video, and conversation. Okay, so our main objective was to record brain activity during audio, video, and conversation, and also to extract different features and analyze the data, also to evaluate deep learning models during between different emotional activities across different modalities. So there are some there are some benchmark EEG datasets are available. Deep is one of them. They collected 32 participants' data over video, over video stimuli, and they analyze their data using Russell's valence aerosol model. There is also another dataset called SEED. They distinguished between 3 emotions: positive, negative, and neutral, using data from 15 participants. Later in 2016, they expand these to 4 emotions, and later in 2020, they SEED 7. They further expand these to 7 emotions. So now let's talk about our data collection strategies. So our participants took 3 types of sessions. First, they spoke to the psychologist to capture natural emotional responses. Okay, then they listened 5 carefully chosen audio clips. Then they watched 5 video clips. Okay, so and audio and video clips are chosen by a team of 5 members, and we chose the video based on the rating and majority voting, that which emotion can be best suited for which video or audio. Okay, and to select the content, we chose the social trending video or audio. Okay, as this type of work is first time in our country, so we had to face some obstacles, like when we tried to set up the device on participants, they felt nervous because they thought that it may harm their brain. Then during session, when participants moves or uh, talks or blinks, eye blinks, then sometimes headband disconnects. And also the proper placement of headband, also a challenging task to ensure our high quality data. So now let's talk about our data preprocessing techniques. So these are the channel locations of our brain, which the TP9, TP10, AF7, AF8. You can look here: AF7, AF8, TP9, and TP10. So now let's talk about preprocessing pipelining technique. So at first we removed our baseline, then we filtered our data set between 1 Hz to 60 Hz, then we set channel locations and reference the data, and then we applied artifact subspace reconstruction, ASR, and we applied it in two steps. First, we applied high tolerance. What it does, it actually cuts out the mostly noisy data sets. Okay, then we applied low tolerance. What it means, it reconstruct each noisy signal in a tolerance level. Then we applied IC decomposition. In IC decomposition, we found out for each channel which component becomes noisy. Then we selected those component and removed them. Then finally, we rechecked once again of our dataset and manually rejected the artifacts which are still remaining. Now you can see the scenario before artifact removal and after artifact removal. So after preprocessing our dataset, we divided our dataset into two second window. As we used we used sampling rate as 256 Hz. So from per window we are from per window we are getting 512 samples, and there is a 1 second overlapping, and which was important to keep the connection between consecutive signals. Okay, so and these are the 5 bands we are worked on. Alpha, whose range is 8 to 13 Hz, beta 30 to 13 to 30 Hz, gamma 30 to 44 Hz, and delta 1 to 4 Hz, and theta 4 to 8 Hz. As all the bands ranges between 1 to 50 Hz, that's why we filtered our dataset between 1 to 60 Hz in the preprocessing pipelining technique. Okay, also we use some features like frequency domain features, some time domain features, some nonlinear features, then correlations features, wavelet features. Then what we get? So this is the power spectrum plot in a audio modality. Okay, so what this plot represents in each point how much energy consumes during emotional activity. Here you can easily see the blue line representing anger declining deeply rather than other emotions, and which clearly shows that during anger our emotion exaggerates immediately. Okay, then compared to other emotions, and the rest of the plots also almost also give the same analysis in case of anger compared to the other emotion. This is all about I already discussed right now. And you can also see the power spectrum plot for our video video modality. So in video modality, you can see that also we found the same analysis about anger. Here you can also see that a pink line representing happy, that declining slowly, because during happy our emotion exaggerates slowly. So this is also a vital analysis for our study. Now let's talk about our performance evaluation. So we applied 4 different models: FNN, 1D CNN, GRU, and BiLSTM over 3 different stimuli: audio, video, and conversation. So audio got the highest accuracy with 92.24%, and video got the moderate accuracy with 89.59%, and conversation dropped the accuracy with 82.43%. So, but over all of the models, we found that BiLSTM outperformed others. As it was also important to it was also important finding about that BiLSTM models works better in such of time domain dataset. So this is the confusion matrices in three models. Okay, now I'm going to conclude by saying that audio got the highest accuracy due to clear emotional cues and focused listening, and video was got the moderate accuracy, and conversation got the lowest. That is because during conversation, participants go through different emotional uh, uh, different positional emotional situations, and that caused because of speech, facial movement, body movement. So that makes the data signal complex to find a pattern for model. So in future, what we are planning to expand our image data set, also expand our emotional dimensions, and we have did subject dependent analysis. So we had a plan to improve our analysis convert into cross subject performance, cross subject analysis. Also, we have a plan to pre-process the our data set pre-process pipe to automate our pre-processing pipelining, also implement end-to-end models, and also create an emotion classification real-time application. And that's all. Thank you. Hello.
Okay. Yeah, Mr. Hassan, nice presentation. And whatever the work that you are doing is also uh, today's uh, core research area. Only thing that I am actually what I have an observation that there are some methods which are already there for the emotion recognition, like facial recognition,
Hmm.
based on the face that people are able to recognize the emotions, and it has already reached to a very what I'll say very good performances, right?
Hmm.
And the
Yes.
performance that you have now just shown based on the EEG signals is still it's still not to that up to that levels. So what is your say about it? Why you
Okay.
have choose EEG only? Why you not choose something else?
Okay, as at first there is a device limitation. In our case, we are using Muse to headband, which has only 4 channels. And using 4 channels, we can use and using 4 channels, improving performance was not enough. And what have you said that classification emission using facial recognition has gotten good performance, and our task was based on EG signals to get the based on the EG signals to classify emotions. So for that, our need as much as possible channel count. Like 2 days, there are studies about 32 to 256 channels study, but we had a device limitation. We used Muse to the headband, which is only 4 channels, and we are working future extending our channel
Okay,
count.
but Mr. Hassan, this is there are even numerous challenges to your particular method. Reason is that, see, if I'm talking about emotions recognition from the faces, I have a multimedia data available across the internet, and I can choose all kind of videos. Those are available online, and I can use it for my experimentation. But in your case, okay, you have to have the subjects get ready. Those who they have to perform basically in a constant environment to show that emotions, right? And
Yes.
pre-processing of the data is again a challenge to you because as you said that you are only using 4 channels, so pre-processing is something which where you need to work really hard because
Yes.
those signals shows EEG signal shows the change of emotion at very small with this very small magnitudes and the time in a time that also in time scale also. So that is something which is very challenging. In any ways, nice attempt. Keep going on. Professor Libro, if you want to ask anything, sir. Professor Libro, sir, any questions, sir?
No, thank you.
Okay. Thank you.
Thank you.
Thank you for the questions.
Thank you so much, presenter, for your presentation. Now moving ahead to our next presentation. A presentation on a modular platform architecture for a product family of functional growth chamber for sustainable control agriculture. And paper presenter is MF Zara. Presenter, you may please start your presentation.
Miss Zara, you are not audible. You are mute. You are mute.
Oops, sorry. Okay. Good morning, evening, or night. My name is Maria Fernanda Caranjo, and I'm part of the Laboratory of Applied Inventions for Industria de Autonomous University of Zacatecas, Mexico. Today I will present the work entitled Modular Platform Architecture for a Product Family of Functional Road Chambers for Sustainable Controlled Agriculture. Well, agriculture is facing a sustainability crisis, alarming data such as the fact that more than 70% of the world's fresh water is used for traditional open field agriculture, and the excessive use of chemicals to improve land yields only serve to exacerbate the problem by contributing significantly to soil degradation. In Mexico, for example, the situation is not very different, with around 77% of water resources being used for agriculture, which is especially problematic in arid and semi-arid regions. Although controlling environment agriculture has shown promise as a solution to this environmental and production problem, and with the combination of controlled environments with soilless agriculture system has shown significant water savings up to 95% compared to open file irrigation, as well as demonstrating accelerated growth in some plants of between 30 to 50% compared to traditional soil cultivation. And exist current commercial systems, but they are expensive, and in many cases they are technological rigid, make them impossible to adhere in low resource environments. This leads to a rapid search for solutions with ad hoc rapid prototypes, especially in low resources academic environments. However, these prototypes end up being challenging to reuse and scale. They can represent a high percentage of material waste when projects evolve, but the technology does not. This creates a methodological gap in the systematic development of experimental agricultural devices. The main objective of the project was to develop a modular platform using an structured conceptual design methodology that will allow for the derivation of multiple functional variants of controlled environment growth chambers, promoting accessibility, sustainability, and technological reuse. The methodology we use is adapted from a work of a Dr. Stone and was developed in three phases. The first involved conducting a needs analysis through semi-structured interviews with researchers focused on technological development for plant propagation under controlled conditions. This is how 55 initial needs were identified, which through quantitative and qualitative filters were reduced by almost 53%, optimizing resources and obtaining a total of 26 truly essential needs for three different contexts of plant growth in a controlled environment. In the second phase, a functional model based on energy, material, and signal flows was developed that captures the basic flows of the basic system, namely energy, water, air, signals, and plant material flows. From this model, through the application of design heuristics also obtained from Stone's work, the interdependencies between main functions were identified to define 6 basic modules as shown in the diagram. There is irrigation module, electricity supply model, lighting model, thermal regulation by air conditioning, control and monitoring, and the growth area. This modular segmentation forms the structural basis of the product platform, allowing for a grouping of operationally autonomous functional blocks. The third phase, based on the basic platform obtained, the design is expanded to 3 conceptual variants for 3 different contexts. The first context is for prototype A, a modern plant growth chamber, which use a vertical design, where the power supply, control, and air conditioning modules are located on the top to avoid interference with the irrigation module located on the bottom, and include nutrient tanks and water infiltration, as well as a misting device in the steam area. And on the other hand, monitoring devices such as sensors and cameras are distributed through to the structure. For the prototype B, a prototype for a small-scale cutting growth chamber, which maintain the vertical architecture and configuration, very similar to the prototype show. The irrigation module is located on the bottom, and the control and power supplies modules are kept on the top. The monitoring sensors are distributed in a similar way to the previous prototype, but in this case, nebulizers and cameras are omitted due to the reduced volume and size of the prototype. Last prototype C, the last prototype is intended for medium scale cutting growth chamber using a horizontal configuration of the modules that allows for independent growth areas interconnected by a common irrigation and lighting structure. The control and power supply modules are located on the top of the sections to prevent them from coming into contact with fluids, and the air conditioning module and monitoring devices are replicated. Only in this case, the irrigation module is separated so that it can supply as many growth modules as necessary, rather than creating an irrigation module for each growth module. All the prototypes use Arduino microcontrollers, facilitating the integration and reuse of components and even modules. As they share the use of control boards, irrigation systems, lighting, and sensors, among others, each variant or prototype is considered part of a product family, which maximizes the reuse or share of modules and components responding to a specific contextual needs. The table below summarizes the functional requirements that distinguish each variant, although the 3 systems share basic features such as RGB LED lighting, pH and temperature monitoring, and other platform models. In the case of the mother plant systems, robustness is emphasized by including more components such as water filter and monitoring cameras. Oh, sorry. Here. Monitoring cameras, the small and medium chambers greatly simplify irrigation, differing only in size and configuration, one being vertical and the other horizontal. These differences validate the platform's modular logic and its ability to respond to real research constraints. The modular designs approach offers many benefits. Some of them are it reduces material by reusing components and speed up the prototyping process. In addition, costs are minimized by using commercial and open source components. And from a sustainability perspective, as these are hydroponic systems, they offer water savings up to 95% compared to traditional crops. And the use of LED lighting ensures efficient energy consumption. With this in mind, the aim is not only to achieve local accessibility and innovation, but also to democratize the research laboratories and educational institutions so that they can adapt and replicate the technology, always seeking to make the process as sustainable as possible by reducing economy and environmental costs. Although the authors, we are aware that the contribution shown here is limited to conceptual design. It should be noted that the 3 prototypes have been implemented. Validation tests are being carried out for presentation in future works. So in conclusion, the study demonstrates a successful application of product design methodologies for modular hydroponic system platforms, at least at a conceptual level. The resulting architectures incorporates essential subsystems for controlling environment, hydroponic growth, resulting in a family of 3 product variants that responds the 3 different user needs, using and sharing standardized models. The approach is scalable, replicable, and particularly suited to environments with limited resources, contributing to sustainable technological development, not only by reducing time and cost, but also through the efficient use of energy and water resources. However, as a part of future work, we seek to integrate renewable energy sources and maybe rainwater harvesting into the prototypes. Thank you very much for your attention. If you have questions, feel free to send them to the contact email address and I will be pleased to answer. Thank you.
I have a small question. This is interesting as the topic of your presentation, but I would ask you, you have talked about some evidence, good way of making the methodology to practice it through modular aspect and etc. I would ask you from an engineering point of view, since we are accustomed to make a model of the system before we implement it, to predict performance, predict the effect of some decisions when we actualize the model. Do you have some experimental data which can give some evidence of good behavior of your model? Thank you.
Thank you for the question. Yes, we implemented the designs I show in the photographs here. There are 3 prototypes implemented, and yes, we have already, but we are making experimentations. So they're not finished, but we are working to have the results nearly in future works.
Okay, okay.
Someone else? Or...
I have one more, Jara. What I'm saying that this is something a modular approach that you people are suggesting for the agriculture. This is a modular approach basically, and as you know that the environmental conditions for the farming, especially in the agricultures, are not stable. They changes time to time. In that case, what means because whatever your experimental method is there, you are acquiring the data with some sensors and then it is being given to some computer machine which is having some algorithms which will be taking decisions towards agriculture, isn't it? So in that case, when the environmental conditions are changing, whether your algorithms are able to adopt those environmental conditions.
It cut the audio. I don't. If you write it, please.
Okay. I'm asking one thing. This is a modular design. Is it okay?
Mm.
Yes.
Mhm.
Now, in the modular designs, whatever the algorithms, computer algorithms are there for deciding the agriculture outcomes, right? In your this system,
Yes, I think.
isn't it? You are acquiring the data. You assume the Arduino boards. These sensors are here. You can see in your pictures. You have shown in your experiments.
The sensors showed here.
You are acquiring the data.
Yes, we're recording the data of the all the sensors
That
of
data is going
pH,
to that data is
temperature.
going to an algorithm.
Mm-hmm. We yes, we are working to not just validate the structure. We are a big team, so my part is the structure, and other people work in algorithms, prediction of ambiental conditioning for different plants.
Does your that other group has some facility to accommodate the environmental changes?
Mm, Not already, but we are working to have it.
Fine. Okay, thank you.
Thank you.
Richa, next.
Okay. Thank you so much, presenter. And now we can call our next presenter to present the paper on part planning for multi-robot task using greedy and A algorithms. And paper presenter is Rihab Hassan.
Hi everyone.
Hello, dear
Hi
presenter.
everyone.
Hello. May
Do,
please start
do
your
you hear me
presentation.
well?
Sorry.
Hi everyone. I'm Hafiz Bada from University Technical Energy of Iraq. My paper path planning for multi-robot task using greedy and ASR algorithm. Problem statement: multi-robot system enable teams of robots to accomplish tasks invisible for single robot. Key challenge: task allocation, obstacle avoidance, and collision-free short path planning. Goal: improve overall efficiency by reduce travel distance and execution time. Objective: assign tasks to robots efficiently in a 2D grid environment. Plan shortest obstacle-free and collision-free path using ASTAR, reviewed by MATLAB. Proposed approach. Step 1. Grid assigns each robot task the nearest unassigned task Euclidean distance by Euclidean distance. Step 2. A star path planning compute collision-free short path or each assigned task. Iterate until all tasks are assigned and execute. System setup. 2D square grid with obstacle 1 and free cell 0. Robot RI at start position. Task TG at goal position. Gradient distance used as a heuristic in the law. H of n stars x1 minus x2 x square plus y1 minus y2 square. A gradient ascent algorithm. For each robot task, pair compute distance using A star cos estimate f of n, g of n plus h of n, where g of n is the distance from start position of robot to the position is the arrive, where and the h of n the distance when the arrive position of robot to the distance goal. Select the task with minimum distance for each robot. Mark task as assigned, update finish time, and show a start bar. Where when the robot finish time can be update to a assigned task. Repeat until all tasks are assigned. A star path finding algorithm. Open close list. Expand nodes with smaller of n, g of n plus h of n. Heuristic h of n, Euclidean distance, and g of n here accumulate cost of wrong start. Return a short obstacle-free path. Integrate with collision avoid. Scenario to scenario. Scenario one, robot position on the task position obstacle after algorithm. Result assignment R1 assigned to task 3. This task 3 here nearest to R1 and R2 T1 task 1 R3 task 2. By the table R1 start position 30 10 7. This is nearest or short distance 7. R2 6 9 30 short 6. R3 11 3 11 3. This is the schematic of the algorithm R1 T3 R3 T2 R2 T1. Scenario 2, robots position, task position, obstacle position after algorithm result assignment R1 T7 T5 R2 T1 R3 T2 T4 T3. In this table, R1 distance one round 5, the short 5, R2 short distance 6 T1 و5 T6 R3 R3 T2 and after round depend when robot finish time can be updated to assign the task. T5 assigned to R1 where T4, T3 assigned to R3. A schematic in the before the algorithm assigned step 1, round 1, and round 3. Discussion. Grid provides fast local decision effect for small to medium size instantaneous. A star successfully returns short obstacle-free path. Robot and robot collision. When robot can be assigned to task and robot the same task, this can be avoided. Overall, reduce travel distance and waiting time across scenario. Conclusion: proposed grid plus A-star pipeline achieved efficient task allocation and safe path planning. Simulation showed collision-free execution and short routes. A grid can be suboptimal for a large-scale system. Need more advanced allocation. Future work apply to real robotic platform and warehouse like testbed. Replace grid with the scalable with method action based on Hungarian meta-heuristic machine learning neural network and explore reinforcement layer for joint education and planning. Thank you for your efficient question.
Can I have a small question? And I would thank you for this topic, which is timely, controlling robots which move each other and avoid collision toward some objective tasks is very interesting. So I understand and agree on the use of a star and other algorithms to choose the best path, the shortest path toward the conclusion, toward a given task. But you talked, I have not heard about real time. When the robot are in the course of making movement toward the completion of a task, I think there is the real concrete difficulty of harmonizing movement of a robot to avoid collision. And can you elaborate a bit your presentation concerning this aspect of real-time monitoring and control of the various robots? Thank you.
Sorry, my English is limited. Can you speak slowly and simply? My language is limited. I don't understand. What do you mean?
Don't understand the
Can you?
question?
Yeah.
No, I would only ask, when you prepare the paths you choose for each robot to which a task is assigned, the destination, the task to accomplish, all of this is okay as a preparatory work. But I intend to have some more in-depth information of what occurs during the real movement of robots, in other terms, real-time behavior of robots. If you have, I think there are surely mechanisms to control robots in real time. And I would only ask some bit more about this work.
Are you mean the time robot to accomplish the task?
The
You mean?
real time. For example, a robot which moves from a cell to another takes always the same time, or there is, for example, different time, so that we have that the robots during movements have to synchronize each other to avoid obstacles, to avoid collisions. And so all of this is concerned with the real-time operation.
I don't understand, but I explain on the time. When a robot finish, one robot finish, can be search what task not assigned. Is there time?
Okay, you have only a simulated model on MATLAB. Perhaps you don't have modeled exactly the single movement and also the timing of each movement of each robot. Okay, it's okay for me. Thank you.
Thank you. I'm so sorry.
Richa, next, please.
Okay, sir. Dear presenter, thank you so much for your presentation. Now we can call our next presenter is Libero, sir, and statistical model clicking of Lemport's bakery mutual exclusion algorithm.
Can you tell me if the video is okay on my slides?
Yes, the video is okay.
It's okay. Thank you. Now, the starting point of my presentation is the following sentence. Proving properties of a concurrent parallel system by informal intuitive reasoning is in general very hard. The source of difficulty are related to an inability of human mind to fully predict the various interleaving of actions of the various processes. This has determined our goal to develop a formal method, formal, based on some tool like UPAL, which allow to formalize the behavior of, in particular, of a multi-exclusion algorithm in which concurrent processes, parallel processes interact each other, and our model, our method can be based both on model checking in the sense that exhaustive model checking of properties, or when model checking is prohibitive to use, by resorting to statistical model checking, so using stochasticity and simulation. This paper in particular is devoted to applying our method to a well-known algorithm, Lamport-Bakheri, which is described on every textbook of operating systems. And everywhere, the algorithm is described informally, intuitively, and one intuitively can have an idea of its correctness. But what we have done is to take the Lamport-Bakheri algorithm and formalize it as a network of time automata processes which interact one another, communicate one another by shared memory register, and prove its properties through an in-depth analysis. Obviously, model checking, but in this case, model checking is prohibitive because Lamport-Bakheri use unbounded tickets, and so this prohibits the use of model checking. So we use only statistical model checking. What is important in our work is that we have modeled and also examined, verified the algorithm in the two important cases of using atomic register and non-atomic registers. When we use atomic register, the read-write operation on a same variable are atomic or indivisible. They must occur one after the other in some global order. In the case a non-atomic register are used, in this case, for example, multiple read operation can co-occur with a process which is writing on the register. So in this case, we have the challenge of correctly study what happens. Okay. Why consider non-atomic register today? The reason is very, very simple, because today there is a plethora of hardware devices, low cost, like cell phones, which use multi-port memory and use a relaxed control memory access. So it is challenging to prove that a multi-exclusion algorithm correctly behavior on these low-cost devices. Now, this is in very short term the behavior of the Lamport-Bakheri algorithm. Here we have the scheme of every processes. There are some global shared communication variable register, an array of Boolean choosing, an array of int number, which are the tickets, and also the process are some local variable, and The behavior of the process is a repeat forever, and it executes a non-critical section in which it is not interested in the use of the so-called critical section in which some shared resource is used. Then it first it acts to achieve like this very simple case, to achieve the next ticket by evaluating the maximum of the numbers, and then by increasing it of 1. When the process has achieved the ticket, it put choosing to false, then the process waits until it has the lowest ticket. Only in this case it proceeds to the critical section in which the process is the only one which access the shared resource thing to a file during an economic transaction. It is fundamental that only one process at a time can enter and make a modification of the data. When the critical section is finished, the number of this process is put to 0 as initially. In this case, it tells to other that it is not interested in this moment to make another access to the critical section. During the waiting part, there are some busy waiting, and in which the process waits if there are some other process which has a greater priority, in the sense it has, for example, a number, a ticket which is lower, or in the case, because it is possible for 2 or more processes to achieve the same ticket, in this case, it is important to use the identifier of the processes to establish the lexicographic order. Now, what we have done is to model this algorithm, which is just an example, and we model it in this way. Every action, in particular, the first modeling considered the use of atomic register. Atomic register implies that when we use a given variable, shared variable, remember that the algorithm uses this two arrays of shared communication variable. Each access to a shared must be executed in a single action. So we put a single action on atomic register. We put it on the exiting edge of location. In Opal, modeling a concurrent system like this is a matter of introducing a number of locations, and in our modeling, in the exiting from a location, we put a single action on the register which we want to use. What is important in our modeling, in this modeling we have used in this paper, is that every action, each action, takes a non-deterministic time, which is compressed in a time window from a lower bound to an upper bound. And for example, 1 to 2, and this uncertainty is fundamental to reproduce in the model the necessary interleaving, the necessary non-determinism. Another important factor of our modeling is when we model the busy waiting loops. This busy waiting here, while a given condition is true, we do nothing and expect that it obviously changes. And busy waiting are implemented by location in which we tentatively exit when the condition could be true. And when we exit, we recontrol the condition, and in the case the condition is false, we come back again in the location which model the busy waiting, okay? when a process has achieved the lowest ticket, it goes in the critical section. Also, the critical section takes a time between the lower bound and the upper bound, and then at the end, it goes again in the non-critical section, and the story recommences. From location L3 to location L5, the process develops the action which are necessary to compute the maximum ticket which is used to define the ticket of this process by incrementing it of 1. Now, what we have done, without also giving so much detail, technical detail, what we have done, for example, we consider, for example, 60 processes, and as this graphical, which we have achieved from Opal by this simple query, MITL query, metric interval temporal logic, we simulate, for example, for 100,000 time units, and then we check the number of processes which simultaneously go, hopefully never go, in the critical section, and also the max value of the overtaking bound. Because every algorithm, mutual exclusion algorithm, to be correct, obviously has to guarantee only one time at a time can enter the critical section, but also it has to guarantee processes never deadlock each other, and also a process which is competing for entering the critical section definitely eventually enter the critical section, so it does not starve. Processes are also not starving, starvation free. In this case, with the 16 processes, you see the overtaking bound is 15, 16 processes, 15, n minus 1 is the overtaking bound, and also the number of processes which simultaneously can be in the critical section is always 1, meaning the algorithm is correct. Okay, this is a table in which we summarize some result, which we used by the statistical overchecking of UPA. For example, for each value of, we consider trivially power of 2 number of processes, and you see that always the critical section, number of critical section is always 1, and you see that the overtaking bound is n minus 1, n minus 1. Absence of deadlocks. Absence of deadlocks is implicitly guaranteed by having that each simulation goes to run to completion in any case without problems. Okay, this also give an idea. We have monitored the number of critical sections that each process is executed during the simulation, and you see that they are handled among each other in a similar way. And you see also that when we use atomic register, the time for simulation of, remember, 100,000 time units is very real time. The real time is very, very low. At most 1 second we take in the case of 16 processes, okay. The property that the overtaking bound is n minus 1 means the algorithm is fair, because in the worst case, one process which is waiting to enter the critical section expects at most n minus 1. It's important this, okay. Then we defined a variation of the model using non-atomic register, which is more challenging. In this case, we have actuated a simple modeling feature, which is in brief, tell to you in this way, in the sense that we capture the moment in which we are writing on a shared register. And if a reader in the same moment reads the register, in this case it achieves a non-deterministic value. If the register is not under writing, the correct last value stored in the register in the variable is used. So in this case, the model admits a greater level non-determinism which complicate analysis. But what we have achieved is that Lamport-Bakhary algorithm keeps the same behavior as with the atomic register. You see, in this case, the same value. But obviously, since the high degree of non-determinism, in this case, the real-time the model executed is very grade with respect to the case of atomic register. Now, to conclude, this example is just one. What we are doing in this moment of applying the modeling verification method to some extension of the Lamport-Bakhary algorithm. In fact, in the literature, there are many algorithms which have tried to extend the Lamport-Bakhary so as to have bounded tickets. For example, we are examining Taubenfeld black and white algorithm in which tickets are forced to remain between 0 to n is the number of register, of two color. So each ticket can be black or white, or the Aravind symmetric token algorithm in which tickets are constrained in the interval between minus n to n. But we have also found another algorithm by this author called the Bakhary plus. And what we have preliminary examined that algorithm 1 and 2 are correct, but when they are operated under atomic register only, they cease to be correct when they are working with the non-atomic register. Instead, the third algorithm, Bakhary plus, our results are very promising because it emerged that the algorithm is correct under both atomic register and non-atomic register. What is very important, in this case, we are using exhaustive model checking and statistical model checking for scalability problem. Okay, because model checking is prohibitive to scale to a certain. For example, we cannot go over 4 or 5 processes, but with statistical model checking, we can go, for example, to 16 processes. Okay, this is my presentation. I thank you for your attention. If you have any question, I'm here to try to respond. Thank you.
I have one question. Doctor, this is interesting topic and deep information. Maybe I don't understand something or some information that you said,
Yes.
but I have one question that may be confused in my mind. My question, how does the Bakery algorithm doorway and waiting phases with the lexicographic order ensure safety and fairness? And what's the memory assumption or limitation we need?
Okay, thank
I
you.
hope you understand me.
I hope to have full understood your question. the point you pose. And I can tell you this about variable state of memory, how much memory we use during the analysis. Please consider that Lambert-Bachery is impossible to model check, and the reason is that tickets are unbounded in the sense that register grow continually. And the model check cannot accept this. So we were forced to use statistical model checking. Statistical model checking does not build the time transition system. You know, the time transition system is the state graph model in which we store every execution state of the model. But the state graph is not built by the statistical model checker, so there is no problem with memory. The only problem that we have experimented with UPAL statistical model checker is related to the fact that during simulation, the UPAL accumulated data, for example, accumulated data to show some graphical graphics which can show some aspect, for example, like this. We want to understand time from time. What is the number of executed critical segment of every process? But if we consider this aspect, in any case, we can simulate the model with a realistic number of processes. And so what we achieve is an estimation, you understand, because we do simulation, not exhaustive model checking, which consider all the possible execution paths in the model. But this estimation are true, in our experience, are true with respect to modeling. And I have also written here on my last slide that we use the OPAL also for making statistical model checking, but we experiment also some scalability problems. We can to go over, for example, 16 processes, which for you, for example, in practical cases, is a small number of processes. But we have also an answer for this because we map the OPAL method one-to-one. So in an automated way on a theater actor system in Java, on a theater actor program in Java, and listen. In this case, we go until 128, 256 processes. And so what we achieve, go over the scalability problem which we have with the OPAL. I don't know if I have responded to all your points.
Yes, this is a
Oh,
clear
thank you.
answer.
Thank you. Thank you.
There is another question that come from your answer. How can we prevent starvation?
Please, please. What is the question?
Yeah, how can we prevent starvation? I hope my pronunciation is good.
This is because
There is a manual. We
how
have
we
in
overcome the scalability problem. This is the
okay,
question.
no problem. I get the answer. I get the answer. No problem.
No, because in this case we execute a Java program, which is a very efficient program because it is not based on threads. And so our actors are very efficient, and we can go over number of processes without problems, without any problems. But UPAL obviously is a toolbox existing, popular, as the problem I have mentioned about.
Thank you, Prof.
Thank you for your question.
Thank you so much, sir, for your presentation. And now we can moving ahead. In this session, we have one more presentation. And regarding the paper title is Analysis of Cyber Security Challenges, Protection Strategy, IT Governance, Compliance, and the Law. And the paper presenter is Aminal Oki.
Okay. Let me share my screen. Okay, hello. My name is Kalu, Edward Kalu Bikala. I'll be presenting on behalf of Dr. Okike. Am I loud and clear?
Yes, you're clear.
Okay, thank you. With all protocols duly observed, I will go ahead to present, make my presentation on the cyber security, governance, and compliance, basic IT protection, and the laws. So here, in order to buttress more cybersecurity for a long time since the inception of internet communication has
Sorry to
become...
interrupt, but your presentation slide on number 5. Your presentation slide is not from beginning.
Oh, okay. Is that okay?
Yeah, it's okay.
It's good now. Okay. Okay, so to make this presentation, the context of the presentation, the content, we will take in the cybersecurity, IT governance, IT compliance, basic IT protection, and the law. Each of these sections explains the practical and the legal perspective of cybersecurity. Now we go to the cybersecurity, which is simply the protection of computer system from unauthorized and malicious access. It also involves multiple elements that may safeguard sensitive information for individuals and also companies, as the case may be. Now, to forge ahead, we'll also discuss the 6 key elements of cybersecurity. These elements are the application security, the information security, network security, disaster recovery, operation security, and end user education. With this all together, they form the backbone of strong cybersecurity framework. Moving ahead, I'll go to the application security to meet up with time. Application security, where we talk about security to ensure the protection of software from vulnerability, threat during development and user. It also helps us to secure our data and the process of handling application properly. Now, as you look at the screen, you can see a pile of a file to also show us on how to handle an information security that has to do with revolving around confidentiality, integrity, and availability. This has to do with this are the 3 principles to ensure that sensitive data are protected, accurate, and also they are available for use by the authorized users, as the case may be. Okay. Now, moving ahead, we go to network security. Network security that has to do with preventing unauthorized access and misuse of computer network using hardware, software tools, common components, which will include firewalls, the VPN, the antivirus, and web security system to cover that. Then when we go to disaster recovery planning, this aspect is very, very important, as we cannot shy away from it. So this is to ensure that the business continuity plans after an incident must have occurred, empower the, in case of power failure, hardware damage, natural disaster. Strategies may include data center recovery, cloud-based recovery, and visualization solutions. Now we go to the operational security. This is to identify and protect sensitive organizational information from threats, which may involve risk analysis, vulnerability assessment, and countermeasures for accomplishing that. Now we also deal with the end user education. End user pose a big threat to security risk due to their lack of awareness. Risk often arises from unsafe email usage, weak password, careless social media activities because of their unawareness. Now, also still on user education, we talk about the regular awareness programs should be created to train the users on phishing, social engineering, device security, password practice, and help them reduce the risk that may come up as a result of their using the system. Now, if we look at the system, we can see the contemporary security challenges. We see the client user, the communication lines, the corporate server, and the corporate systems. The modern IT system faces this vulnerability from the disaster techniques, failure, human error, in summary, unauthorized access, abuse, and fraud that are commonly reached in digital systems. Now we talk about moving ahead, we talk about why the systems are vulnerable, because they are a result of errors, unauthorized access, denial to service attack, and malicious software can interrupt IT systems, and hardware failures. Poor management of decisions added to the vulnerability. Now we go ahead to talk about security mobile, that the MANET, mobile device communication, which is the MANET, without centralizing infrastructure, making router security critical. Misrouting can also enter into network and can make essential to manage vulnerability and threats. Now, this side, basic MANET structure. Look at the basic MANET structure. This illustrates the architecture of MANET system, and it highlights the potential risk from both active and passive of the MANET network. Now we talk of the protective strategies. To protective strategy, we'll talk about including application level security, strong firewalls, safeguard sensitive data, organize much follow IT governance policy and standard for effective protection. IT governance. In short form, IT governance, this is to ensure that IT practices align with the organizational goals while complying with global security laws and standards. It also addresses vulnerability in networks and also in systems. Still on IT governance, by definition, it is a structural process of ensuring efficient IT use to meet business objectives. It also requires executive board level support for effectiveness. IT governance has a framework that align with IT security with laws, policies, business objective. The framework is for multiple definition, highlighting the risk management and accountability as core aspect of the IT. Now we go ahead to talk about IT governance framework 2. This, which include bodies like ITIL for service management, COSO for corporate governance, NIST/IO, ISO standard for IT security. These frameworks provide efficiency, compliance, and customer services protection. So I will go over to IT compliance. IT compliance, because of time, IT compliance address IT threat vulnerability through manual risk assessment. Frameworks like COSO, ISO 20002, IOS help organizations to maintain the compliance. Okay, now we talk about basic IT protection. Basic IT protection, like that of the German IT Grundes, provided a standard for IT security. It included guidance on information security management, risk analysis, and emergency management in case of a occurrence of threats. Now we talk about the IT law, which is very, very important to state. In the IT law, we have the e-commerce law, we have the IT contract laws. Now, in IT laws, this includes intellectual properties, it's IT contracts, privacy law, economy regulation, service level agreement, and compliance requiring the requirement that differ across countries, as the case may be, based on their economic values. Still on IT law, we talk about, we have the IP law protecting patents, trademarks, copyright in digital and AI technology, competition law that prevent monopolies, and safeguard minors in IT environment, because the IT environment is used by all. Case like YouTube, about $1,700 million fine for collecting children data highlighted strictly regulation. Laws also address domain name issues such as cyber quoting and typo quoting. Organization must, on the issue of email and copyright, still on IT law, organization must maintain security, encryption, email archiving, and follow breach notification laws. Copyright laws which protect creators' life, creating common license allows safe sharing of information within that space. Moving with time, I will go ahead to talk about the compliance challenges. Compliance challenges, which involve technology and rising cyber threat, demand consistent regulation of regular content. Organization must also adapt quickly on avoiding consequences of non-compliance of these laws. Now, moving ahead, still on that, we say, one, rapid challenge in laws, lack of resources, limited skills staff makes compliance difficult because specialized tools and integration of proper security measures are also challenging to maintain. This point, if you look at the table here, this is a compliance framework for standard and the standard for monitoring it, where we have the meaning, the region, and the focus. Like one, we have General Data Protection Regulation from Europe Union, data protection of EU residents. Finally, we have Sarbanes-Oxley Act, USA, protection of inventors. So in my conclusion, I will state that by carefully adhering to the IT governance, the compliance, and basic laws, will go a long way to create a safe cyber security environment and will limit the level of challenges. Thank you.
Thank you so much, presenter, for your presentation. So do you have any question?
It appears to me as a review of cyber security and related parameters or features, I would say. And, important thing is that I would be glad if you can tell me about the system or setup that is required for cyber security across the globe. It's a multinational. The cases like say some particular region, if it is covering, what cyber security setup you can think of?
Please, sorry, Doc. Can you take the question again, please?
Okay. I was asking that how do you see cyber security in a global aspect? Okay, Richa, I think I'm not reaching to
Okay.
the.
Are you done, sir? Okay. How I see cybersecurity on a global aspect, it goes beyond just for me. It goes beyond just protecting computers and network. It also touches almost on every dimension of modern life, because this also has to affect since the inception of this internet communication. So I may just say from my side, the rise of this class computing or OI, it goes beyond just normal, but it can also affect other areas of walks of life. Like for instance, my former profession in the military, when you talk about cyber security, here we now talk about they need to know, they need to hold, and they need to take, that has to do with those vital and classified information. How do the protection of all those information as it roots on operational information that when tampered with may affect operation and leak information to the enemy's position. It all depends on different walks of life too.
Right. Okay. Thank you.
Thank you so much, Edward. I have one concern regarding your presentation. Your
Okay.
name is not mentioned in a final CRC. So,
Okay.
is there any update
Okay.
regarding the same?
Okay. When I started, I said I am standing in for Dr. Okike.
Okay. Okay, so
Yeah,
you,
he's hospitalized, yes.
okay. Okay, then got it. Thank you.
Thank you very much.
Oh, thank you. Thank you so much, everyone. And now we conclude this session. I sincerely thank our author for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And we, on the behalf of the whole team, thank you for your support during 9th version and the all previous 8th version of this conference. We will be happy to have you in the 10th version in 2026. All the presenter would be getting digital certificates through within 2 working days via email, and the publication will be live 7 to 8 months. Kindly cooperate with the team of WS4 2025. I also thank our chair of this session, Professor Narendra Londe sir.
Excuse me, can I speak to Prof. Lebro?
Thank you so much, sir, for your valuable time and your presence. And this is a token of appreciation on behalf of WS4 team. And I kindly request to turn on the camera for a quick snapshot for this virtual conference. Thank you so much, everyone. And thank you so much, Libero sir, for being a part of this conference and for your valuable comments regarding presentation. Thank you so much, sir.
Thank you.
Excuse me.
Thank you.
Can I speak to Prof. Lebro? Prof. Lebro?
She want to talk with Prof. Libro.
Thank you so much, everyone. Good day.
Thank you, everyone. Wish you all the best. Thank you so much. Bye.